Day 190 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. Y'all already know how we do. We're doing LeetCode problems every day until we get a job, we accomplish our goals, or we build that app that we're trying to build, y'all. We're all here to be the best programmers that we could be, and we won't accept anything less from each other. Why? Because we're Swift programmers, and we're all here to encourage each other to keep going, to keep pushing through until Swift is the new Python. You know what they say? Swift is already the new Python, but it wouldn't be without great programmers like ourselves, y'all. That's why we have to encourage each other to stay disciplined and stay consistent and keep pushing through, y'all. It's not going to be easy for us as Swift programmers. You know, we have a large mountain that we got to climb, but we're not worried about the journey. The journey is the reward, y'all. We're going to climb that mountain until we get to the top, and we're the best programmers that we could be, y'all. So just remember, if you're feeling any sign of burnout, don't stop, y'all. Keep sticking with it, y'all. If you're thinking about switching programming language, don't even worry about it. Stick with it, y'all. We sticking with Swift, y'all. We made up our mind. We're doing what we have to do to be the best that we can be. We're gonna be shooting in the gym longer than any other programmers out there, so it's not even gonna matter, y'all. Now, before we get started today, don't forget. Bring a mouse right over here and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. Then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could push this content out to a larger audience, y'all. As Swift community members, it's up to us to help the community to grow. And one way we could do that is to help push this content out with as many people as we could find that will watch it, y'all. So your support is appreciated when it comes to that. Now, I know why y'all here, so let's get into the question. And today we have question number 45, Jump Game 2. We did Jump Game 1 yesterday, so if you missed that, go ahead and check out day 189. We did Jump Game 1. They're both medium questions, and this question today is a medium, so you already know we're going to keep the solution as simple and easy to understand because we're all here to learn something. And if you don't understand the solution, then you probably didn't learn anything. So don't worry about the medium difficulty. Don't let that deter y'all. We're going to get through it and we're going to understand how we got through it. So, first part of understand the solution is we have to understand the question. So let's get into it. The question says you are given a zero indexed array integers nums of length n. You are initially positioned at nums 0. Each element nums I represents the maximum length of a forward jump from index I. In other words, if you are at nums I, you could jump to any nums I plus j, where 0 is less than or equal to j and j is less than or equal to nums I plus j is less than n. Return the minimum number of jumps to reach nums n minus 1. The test cases are generated such that you can reach nums n minus 1. So let's break that down. It's pretty self-explanatory. This time we want the minimum number of jumps, right? So let's look at example 1. Example 1, we have the input nums equals 2, and the input nums equals an array of integers 2, 3, 1, 4. 2, 3, 1, 1, and 4. The output is 2. Explanation says the minimum number of jumps to reach the last index is 2. Jump 1 step from 0 to 1, index 0 to 1, and 3 steps to the last index. So let's break that down, right? So first we have to remember, so we're starting at 2. We have to remember that 2 represents the maximum length forward jump of a forward jump from index I, right? So nums I, in this case is 2, represents the maximum length of a forward jump from index I, right? Keyword maximum, meaning we don't have to use the whole 2 steps. We can only use 1 step if needed to be, if that's gonna decrease the number of jumps needed, right? So in this case, we have 2 steps that we can use, but we're only going to use 1, right? So because 2 is the maximum, meaning we can use 1 if we want to. So we're going to use 1 step and we're going to go to 3. Boom. Now we're at 3. We're going to use those 3. We have 3 maximum jumps that we can use. We're going to use all 3. So we're going to go 1, 2, 3. We land on 4. That only took us 2 jumps, right? We went from 1 to 2, and then we jumped from 1 to 2. We jumped from 2 to 3, and then we jumped from 2 to 3, and then we jumped from 3 to 4. Boom. Those were the only 2 jumps we needed. That's why the output is 2. Let's look at example 2, where it's pretty much the same thing. They just changed this number right here. This is the only number they changed. But it is important, I guess, because, well, let's go through it. In example 2, we have an input nums equals an array of integers 2, 3, 0, 1, and 4, right? The output is 2. So we already know we can do the same thing we did last time, because it's the same. We could do the same thing we did last time because we don't even use this number. We jumped over this index anyway, right? We could go from 1. We could use 1 jump and go from 2 to 3. Then we could use our final 3 jumps and go 1, 2, 3, and go to 4, just like we did up here. But this 0 is a little tricky because, or they try to make it tricky because, say we went 1, 2, and we used our 2 jumps here off bucks, right? Say we used our 2 jumps off bucks and we went 1, 2, went to 0. We would not be able to reach the end of the array anymore. We stop at 0 because there's 0 jumps up here. Whereas opposed to up here, we could use our 2 jumps. We go 1, 2, we go to 1, then we go 1 more, boom, to right here. Then we go 1 more to right here, which would be, that'd be 1, 2, 3. That would be 3 jumps, but we would still make it to the end. But we want the minimum number of jumps. That's why we didn't do it like that, because we could just go from 2 to, we go from 2 to 3, that'd be 1, and then we go 3 to 4, that'd be 2 jumps. We want the minimum number of jumps. That's why we didn't do it like that, where we go from 2 to 1 to 1 to 4, right? Because that'd be 3 jumps as opposed to 2 jumps, and we want the minimum number. And that's the only difference I see in this example, is they put the 0 there. So we have to do it like how we did it. We have to go from 2 to 3 and then from 3 to 4, because if we went from 2 to 0, we'd be stuck at 0 because we'd have 0 jumps. But that's neither here nor there, right? The output is 2 because we did the same thing that we did in example 1. We went from 2 to 3 and 3 to 4, right? So now that we understand the question, let's get into the fun part, the actual code. Not that difficult at all. We're going to use a sliding window, y'all, so get excited about that. We haven't did one of those in some months, so let's get into it. First thing we're going to do, we're going to declare a variable called result. Excuse me, y'all. Result, we're going to set that equal to 0. Then we're going to declare a variable called L, set that equal to 0. Then another variable called R, set that equal to 0. Then we're going to come down here. We're going to say while R is less than nums.count minus 1, open up the brackets. We're going to say declare a variable called farthest, boom, and we're going to set that equal to 0. We're going to come underneath that. We're going to say for I and L, 3 dots, dot, 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 up to R, open up the brackets. We're going to say farthest equals max farthest, comma, I plus nums, square bracket, I. Then we're going to come underneath that for loop, but still inside the while loop, and we're going to say L equals R plus 1. Then we're going to say R equals farthest. Then we're going to come down here. We're going to say result plus equals 1. We're going to increment result by 1. Come outside of the while loop, and we are going to return our result like so. Then we're going to run it, see how it runs. Let's see, drum roll. Ooh, okay. There's a typo. This should be result, not result. So let's run it again. Start the drum roll over, and it's accepted. So let's submit it. Make sure it stays accepted. Let's see. Oh, look at that, y'all. 0 milliseconds faster than a Bugatti riding past Andrew Tate and the rest of the brokies down the highway, y'all. That's what I like to see. Wave at the brokies for me, y'all. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.